Hello and welcome to Chapter 9, Implementing the Cisco Adaptive Security Appliance. Now we're going to move into a new appliance, completely separate from our routers. So this is a separate appliance that has a VPN in it, a firewall, and an IPS, and also can provide us a failover redundancy, which we'll discuss later on. So if you have a small network, small company, an ASA will be very useful for them. So you want to take off all, instead of having our routers do the routing and the DHCP and all, and the firewall and the IPS and the VPN, you can have those three major security appliances in one device. And so you should implement that right in front of your router. Anyway, so let's get into discussion of the ASA. In this chapter, we'll talk about the ASA. There are some commands that are going to be a little bit different than what we usually do in our routers, in our Cisco routers. And then in chapter 10, we'll get into the GUI version of the ASA. We'll see how we can use the GUI version to do firewalls and IPSs and even routers and just basic configuration of the ASA itself. Okay, so let's start. Um, Here are the typical types of ASAs that are available. As you probably have seen already in our labs, we have the 5505 one. They're pretty, they're not that expensive. Uh, if you have a small office, branch office model, you can easily get these, and they do a pretty good job. Um, there are ones that are a little bit more expensive. Typically, the speed is much better. But for our labs and for a small office, you probably don't need more than this, more than the 5500. Brand new, straight out of Cisco, they may cost you close to $500, but you can probably get it for less than 50, $60 off on eBay if you wanted it used. You can go at the internet if you wanted to connect to the internet. You can get up to 4 gigabits per second connections on this model, the 55, the quad fives, or the enterprise data centers. I mean, these are then become a little bit more expensive. So you can get close to 4 gigabytes, but we'll be concentrating on the lower end. All right, so remember, I wanted you to take some notes. So the ASA, just to go over this one more time before we get into what features it has. It's a proven firewall technology. It has an IPS in there, VPNs, and a failover feature for fault tolerances. And also, it will allow us to do with the Cisco Adaptive Security Virtual Appliance, you can have virtual domains, which we'll discuss also later on. All right, here are the 4 things that I want you to do, the features that ASA had. Number 1, ASA virtualization, which means, so write this down, that's the first one. ASA virtualization, that means you can have one ASA can be partitioned into multiple virtual devices. So you can have, one device, 2 device, all virtually within one machine. You can have high availability, which means with failover, that means one can be used as active and another as a standby. I don't know, in the CCNA 3 class, we did that with routers with the HSRP when we have a redundant router, if you remember. So ASA can do the same thing. You can have one standing by in case it fails. In case the primary goes down, then the routing will go through the ASA to be routed outside. So, PC1 will always use this ASA to go through. And if this fails over, the ASA2 will immediately, the standby will get active. Number 3, you can have an identity firewall. That means you can have an optional granular access control based on an association with an IP addresses to Windows Active Directory. Typically, we don't do that as much unless you have a Windows server installed in your system. And finally, um, we can also have threat control and containment services. All AS models support the basic IPS features. Okay, so those are the four things that I wanted you to write. ASA virtualization, that's number one. Number two, high availability with failover, identity firewall, and threat control containment. All right. So the firewalls themselves, it can work just like regular firewalls. So you have an inside network, an outside network, and a demilitarized zone. So you would name them, and you can easily control the traffic, the permitted traffic or denied traffic, depending on who you want. So, for example, if you don't want any data coming from the outside, you can set a deny. Anything from the DMZ coming into the inside network, that also can be denied. And you can set, permitted traffic to go out from the inside out to the outside, and from inside out to the DMZ. All right. Here's another thing that I want you to write down. Remember, when you write these down in Microsoft Word, I want you to submit them as proof that you have did the assignment. And the assignment, of course, is viewing the lecture notes. All right, there are two modes of operation with ASA. There's the routed mode. It acts less like a router. So a routed mode is when you have two or more interfaces separating layer 3 networks, just like a regular router where you have one LAN here and one LAN on the other. Or the other mode is the transparent mode, where you have the ASA is only assigned an IP address on the local network for management purposes. So you just like a regular switch, where you can connect to it and manage it using the IP address. All right, so write these down. The two modes that it can operate in: routed mode, acting like a router, or transparent mode, acting like a switch. All right, so when it comes to licensing requirement, these are the licensing requirement if you have one. The ones that we got, we already have the license installed. We don't have to get into this right now. Let's just skip that for now. All right, let's get into the configuration. Okay, so you have the USB drive here on the back of the ASA. This one, if this lights up, that means you're running, the link act is running 10 gigabit. And if this is light up, the green, that means you're running at 100 megabits per second. This is the power, telling you that the power is on. The post test runs just like a regular router. Then you have the status, active if it's blinking, everything's okay. If the VPN is blinking, if it's green, that means you have the VPN is active as well. Okay, you have this is a typical switch, 100 megabits per second. Then you have two Ethernet, also a gigabit Ethernet. All of these are regular, just like a regular switch running at 100 megabits per second. This is the power, the console port where we have to get in, and two USB ports. If you press this button and to reset it, so if you want to just delete all the configuration and bring it back to the factory default setting, just press the reset button itself. In class, you'll be able to go through this when we're doing it in the lab. In this chapter and the next chapter, a lot of the information that we're going to do, because most of the information there is really no new concept here, is the idea is to make sure that you know how to use the ASA, how to configure it, because we've already been through how to configure firewalls, IPSs, and VPNs. Now we just need to know how to implement it on this ASA. All right, so the security level controls. There are ASA security levels. They have security levels go from 0 to 100. And it helps control many aspects of the network traffic, such as application filtering, network access, and inspection engines. So please write those down, the security levels, and it's the network access inspection engine and application engines. So 0, if the security level is a 0, that's untrustworthy. 100 is very trustworthy. So if you're getting traffic coming into the network, and if it's coming from the outside, and that means it has level 0, that means nothing is on, it's untrustworthy. That means the firewall is going to check all the data in details. All right. If it's coming from the DMZ, you may have a security level of 50. If it's coming from another inside network, it has a level of 100. Right. So it all depends, and we'll be able to see that as we move along. All right. So where do you place the ASA? If you have a small network, you have your VLANs, you can put it right in here, just like in your router. It can be in the place of a router if you wanted to. You can directly connect, if you don't want a router, if you have a very small network, you can connect it directly, connect your devices directly to the ASA, right? And, those ports that we've seen earlier, you can actually connect those to a switch, and each port can be connected to its own VLAN if you wanted to. If you have a small branch office, you could do it this way too, where pretty much the same thing, but you have a DMZ zone where you can have a web server where, outside users can access the web server in the DMZ zone, of course. In an enterprise network, pretty much the same thing. So you can have, this is one of the biggest ASAs, so you can have a VPN connected between them. So if you have a headquarters and you have 2 branch offices, so you want to put 3 ASAs in there, and we could set up an easy VPN between them. And you'll be able to connect these as we will see later on. All right, let's take a look at the configuration. The configuration is a little bit different than our regular routers. So I know this might be taking a little bit, take a little time. Create a little table and please write these down in a little table. I want you to be able to know that, how to write down the commands in the ASA mode and see how it is related to the old iOS router command. So for example, if you're going to type enable secret password in the ASA, you just type enable and the word password, and then you type in your password, because everything is automatically encrypted anyway. In the old router, you had a plain text password and a regular secret password, and a secret password that's encrypted. In ASA, they're always encrypted. The line VTY, so we don't have to type these 3 different commands to do the Telnet password. So all you got to do is type passwd, and then you type in your password. All right. When you type IP route, you can say route outside, and we'll see all of these commands. For now, I want you to create the table and write these down, because I want you to have these notes with you. This will help you when you are configuring your router, your ASA. All right, so it's pretty much the same thing, by the way, getting into the 4 different modes. You go from the user mode by typing enable, type in your password. You can type config T, and they can type int, for example, your Ethernet interface. All right, if you want the help command, so you just type help. Remember, in the old router, you have the question mark. You can type in the command front line, front slash question mark. Here, you just type help and space right, and it would give you a description of all the parameters that can go with the command right. So this, if you don't know how, the different ways of using the right command, just use the help. All right, so here are the default configurations that you have with the ASA. So you should definitely know. Oops, let me just go back a little bit, because I really wanted you to see this. Host name, you have to have a host name. Domain name, You have to create that as well. And the enable password, the message of the day, banner, that's not even up here. But these, okay, these are by the default. You can actually do each one of those. Type these in. Let me see. Host name, Cisco CCNA, the password. You can create an interface and switch it to the VLAN 2. And then interface VLAN 1. Then you give it a name interface. That's what the IF is called inside. And this way we gave VLAN 1 because it's an inside VLAN, a security level of 100. So all the data that's labeling VLAN 1 will have a security level of 100, very trustworthy, all that data. And the IP address for that VLAN. VLAN 2, that VLAN 2 interface, which is a port on that ASA, we're going to name it the outside, that's connected to the outside world. And it's going to have a level 0. And the IP address is going to be DHCP set route, which means it's going to get an IP address from the ISP. And we'll talk about the network objects as we go down the road. HTTP server enable, that allows us to access the ASA GUI version. Again, we'll discuss that as we move along. We'll discuss the rest of this as we move along in this chapter. All right. You can use the Setup Initialization Wizard if you wanted to. So when you turn on your ASA, a pre-configured firewall now through into, if you answer yes, and it's set up as a, you set it up as a routed, which means it's connected to the outside world. You set up a Cisco and enable password, asking you questions. You don't have to do any configurations. And once you go through all of this, then the configuration is all done for you. You don't have to worry. You don't have to set anything up. As long as you take your router, you set it up to the outside world, and you give it the correct IP address, then you'll be good to go. But we're not going to do that, of course. We are going to create our own configuration for the router. All right, so let's take a look at configuration, the configuration of the ASA itself. Okay, so you type enable just like the old router, type in your password. You can set the clock by typing clock set, and you type in whatever the time and the date. You can go by typing config T, get into the config mode. Okay. All right, so here are the basic configuration commands. Please write those down. For example, just the name. You don't have to write the description, because I want you to know at least the basic configuration command when you get into the router. Remember, when we always get in, we always type enable config T. The very first thing we do no IP domain lookup. We don't have to do that here. And we always do host name and all that other stuff, the basic configuration of a router. Here we're doing the basic configuration of ASA. So please write those down. You got to do the host name, a domain name, and the word name, you just make up whatever you want. The enable password, which always will be encrypted. Banner message of the day. And you're going to type in a key config. So this is going to be for creating encryption keys down the road. So just type key, let me see here, key config key password encryption, and then you type in whatever passphrase you want. And then you're going to use the AES as the encryption method of encrypting all your passwords. So those are the basic configuration that you should set yourself up. Here's an example. Host name, CCNA ASA. The domain name is ccnasecurity.com. The enable password is class. Here's a whole bunch of banners that's going to come up. Wanted to, you can, and when you exit, this is what comes up, right? Whoops, I'm hitting this too fast. If you type show password encryption, you see that it's been disabled. You go to config T and you type in the key, config key password encryption Cisco 123, and you're going to use the AES to encrypt the data, to encrypt that password. Okay. If you wanted to go into an interface, so you would type in interface, let's say VLAN 2. Um, and by the way, remember when we used to type in VLAN 10 name students? Well, now, well, in here, what you do is you type interface VLAN and you type in a number, interface VLAN number 10. And then instead of writing name students, you're going to type name IF, and then you type in students. Usually we say that this is the inside and this is the outside if you want it to, depending on the name that you want it to. So, and then you set the security level. If the interface that you're going to be connected to is going to be connected to the inside LAN, then you usually write the if name is inside. And if the other interface, the other VLAN is going to be to the outside, to the internet, for example, then you write in the word outside. Maybe a third interface will be connected to the DMZ, and then you write name if DMZ. Because typically you may have 3 VLANs, right? 10, 20, 30. Number 10 will have the name inside. Number 20 will be the outside. Number 30 will be the DMZ. And then you say security level, right? From 0 to 100. If it's the inside, you give it 100. If it's the outside, you give it 0. That means all the data, you want the ASA to pay attention to all the data that's coming in from the outside interface. And if it's a DMZ, depending, give it 50 maybe, right? All right, now setting up IP addresses on VLANs. So you just type IP address like we've always been doing it. Setting up a DHCP, you type in IP address DHCP, IP, and all of the, IP address set route to install the default route, which we'll see also in a few. PPP over Ethernet, you'll be able to do that as well. All right, so here's an example. So please write this example down. So example of setting up VLAN interfaces. So interface VLAN 1, and we named it inside. And we gave it a security level of 100, and we gave it an IP address on that interface. So now we can actually telnet to this. So this VLAN 1 is set, is going to be on the inside. VLAN 2 is going to be connected to the outside world, right? Has a level of 0. So please write these down. How to set a VLAN 1 and a VLAN 2 on the ASA. Then we take the interfaces on the ASA. For example, the Ethernet 0 interface is going to be to VLAN 2, and Ethernet 01 is going to be to VLAN 1. So whatever is connected to VLAN 1, that's going to be from the inside network. And whatever is connected to VLAN 2, that's going to be the outside. Don't forget to type no shut, of course. Please write those down as well. So the first thing you do is you create your VLANs. Just to go over this one more time. You create your VLANs, give them names, right, and IP addresses, and set the security levels. And then you, just like we've been doing before, switch port access. You don't have to do, by the way, switch port mode access. It's already been accessed. You don't use the ASA for trunking or any of that stuff. So they're always going to be in access mode. So all you have to do is just say switch port access to VLAN 2 and then type in no shot. All right, this will show interface IP brief, by the way. We don't type show IP interface brief. So you just swipe these two with the ASA. Okay, so this is going to tell you all the 8 interfaces to see if they are up or not. Right? A quick way of finding out if these interfaces are active or not. How do you do an IP route, a static route? This is a typical static route. So you type in IP outside. Remember we used to type in IP route quad 0 out of this interface. So now we're going to say IP, instead of writing IP route, you just write the word route out of the outside interface, quad zeros, and this is the next hop. Okay? So the outside is the interface name, and the 209.165.200.225, that's going to be the next hop interface. Okay, he's a Telnet example. Um, so write this down, please, because this way you'll know how to set up the ASA for a Telnet. So you type in, all you have to do is type password Cisco, and you're going to say Telnet 192.168.1.3, 4255s inside. So what this means is the host 192.168.1.3 from the inside network is the only one that can telnet. That's what this means. That's why you got 4255. So you say telnet only this guy, the 192.168.1.3 from the inside network. He's the only one that's going to be able to telnet. Telnet Timeout 3 means that if after 3 minutes of idling, the session will time out. By the way, the default is 5. So if you don't type this command, after 5 minutes, you will time out, and then you have to re-enter your password to be able to get in. Okay, so write this down so you'll know how to set up Telnet on an ASA. How do you do an SSH? Okay, again, I want you to write this down. So username, password, AAA authentication, SSH console logo. You create the crypto key, 2048. Let's see what the key to be, excuse me. And again, here are the 4 different people that can SSH, 4 different users that are allowed to SSH. And that's it. So here's allowed, and that's all you have to do. Simple as that, right? So if the name of the interface is not specified, by the way, then the host can SSH from any interface default. So if you don't write this inside or outside, then this user can telnet from anywhere, can SSH from anywhere. So, but because I wrote inside, he has to be able to SSH, he has to be coming in from the inside. All right, so makes more sense. All right, setting up the NTP, the network time protocol. Again, write this down. These are the basic configurations for the for our ASA. So you type NTP authenticate, NTP trust key 1, and NTP authentication key 1 MD5. Then you type in your password. In this case, it's Cisco 123, and then the NTP server that you're going to synchronize with. The DHCP. So you type in DHCP address, and you type in the range of addresses that you are going to lease. Then you say IP DHCP from here to here from the inside. If anybody comes in from the inside, they'll be given an IP address from this range. The addresses, you have 32 addresses, are limited. Then you say, well, here's the 32 addresses from the inside. So the lease is for 1800 seconds. So after 1800 seconds, you'll be able to, this is typically for remote users or users that are wireless, I mean. You'll be able to do that hopefully in the lab. All right, let's talk about object groups, which is something new, and we have we're going to have to introduce in this chapter. So object groups are created and used by the ASA in place of any inline IP addresses in any given configuration. An object can be defined with a particular IP address, an entire subnet, a range of addresses, a protocol, or a specific port, or a range of ports. The object can then be reused in several configurations. So this is like in C language where you can create a function. And if you, or I don't know if you guys ever did C, C++, or Java, where you create functions, and in the main program you can call these functions whenever you needed them. Same thing right here. We can create objects. For example, we'll create an object that has a whole bunch of addresses in it, a range of addresses, and we can use these in for example, ACLs, and just call the objects. I want the following subnet. I'll just call the name of the object, and the name of the object has all the addresses that are permitted. And I say permit object so and so, and in the object I have all the addresses that I want. Every time I want these addresses to either permitted or denied or have access to certain things, I'll just call the object and just create them once instead of having to retype all these addresses over and over again. All right, but there are one, two, three, four, five different options that you can have. And we are going to look at specifically the network object and the service objects. Now, again, these objects can be used in NAT access lists and object groups. Specific network objects are a vital part of configuring NAT. Makes NAT much, much easier when you are configuring it. So the command to create an object, all you have to do is type object-group, and there's all your different types of objects that are available for you. So a network object specify a group or a host or a subnet of addresses. A service object it specifies a group of TCP or UDP ports and services. We'll see that, and you'll see how easy it is to use objects. It makes the configuration much simpler. Okay. Some commands that you are going to be needed. Here's an example of creating a network object. So you say object network and you give it a name. In this case, it's example 1 and a host 192.168.1.3. So if anytime you want to call this network object network, anytime you call this name example 1, it will have this command in it. It's as if you are using this command. You can change it by adding another range. So now example 1 has 192.168.1.4 and this address and this range of addresses as well. All right. Object service. Here are the different types of services that you could do. So let's take a look at some examples of that. Object service serve 1. So service TCP destination equal FTP, service TCP destination equal World Wide Web. So you can always use this object serve whenever you want to do, in ACLs. You want to do these two commands. So you don't have to keep retyping this. You just type the object service serve-1. All right, so the object groups are the network, the service, their security object, ICMP types for pinging, and they are user objects that you can have. Here are some configuration of common object groups. So object group network admin hosts. You give it a little description in case you ever need to look at it. So in this case, these are the administrative hosts. Here's a network object. There's a network object host 1.3 and 1.4. All hosts, so you give it the range of addresses. Here's an ICMP type called ICMP allowed. So object echo and ICMP object time exceeded. So you'll see you can actually put these in NAT or ACLs by just calling the ICMP type object. Makes it much easier. All right, so here is a good example of a service object group. So you create the object group service 1. So there are 4 different service objects. One for World Wide Web equal World Wide Web, HTTP. So you're allowing, you're not even allowing or denying. You're just saying this service is going to be for World Wide Web, HTTPS, POP3, which is the email server retrieving of your emails, and the NTP. The other service 2, the other object service 2 is going to be for ports World Wide Web and SMTP. And the third one is going to be object. You're using this whole thing, object 2. You can put it in there. Plus, you're adding FTP and this range of ports as well. Okay, let's look at ACLs. When it comes to ACLs, here's what I want you to write down. Although, you know what? Yeah, write these down. It uses a network mask, by the way, instead of wildcards. So when we are doing ACLs, we do not have to write wildcards anymore. ACLs will always be using names. We do not use numbers anymore. Not with the ASA, of course. By default, interface security levels apply access control without an ACL configure. So if you don't have an ACL configure, depending on your security level, you're immediately going to have access control done to it. So you're going to be checking all the data that's coming in. If you have a security level of 0, for example, there is a firewall that is automatically configured because all the data that's coming in from that specific interface is untrustworthy. Identify addresses for NAT. They also identify traffic for AAA rules. They establish VPN access, and they also identify traffic for modular policy framework, the MPF, which we'll talk about later on. All right, so please write these down for the rules of the ASA ACLs. All right, so here's a typical interfaces. These are interface 02 is on the inside. Remember, we created a VLAN and we gave it a security level, just remember earlier. Ethernet 00 is on the outside. It's going to be given a security level of 0. And Ethernet 01 is the DMZ, given it a security level of 50. So since this is 00, immediately you'll have all automatic firewall, and all the data is going to be checked in to make sure that it's okay. But anyway, we'll get to that later on. So here's a typical lower level denied access. So any data coming in from the outside, because it has a security 0, they're immediately going to be denied going in. All right, so they also have extended and standard ACLs. And there is an IPv6 ACL example as well. All right. Again, you can use the help command to use the access lists if you wanted to. There are, by the way, several types of, 5 types of ACLs. There is the extended, the standard, the ether type, by the way. And the ether type is only if the ASA is in transparent mode. Web type that supports filtering for clientless SSL VPN, which we'll discuss in the next chapter. And the 5th one is the IPv6. All right. This is all the different commands that we're going to take a look at. The best thing to do is by looking at an example. So here's a typical reference topology. So you have an ASA. Ethernet 0 is set up to the outside. Ethernet 2 is to, and Ethernet 01 and 02 are going to be the insides. So they will automatically get, security level of 100. This is going to get security level of 0. But we're going to apply ACLs on them anyway. And here's the networks, /27. This has .132 network. The .132 IP address, this is 131, and this is the outside wall. So this is typically, you may think of it the inside, but it could be a DMZ zone. Okay, so here are the ACLs. So access list ACLN, you're going to have a remark for it. PC1, this is just a description. This is to permit PC1 to server A for HTTP. So you create the ACLN to extended, access list ACL extended permit this host equal HTTP, blah, blah, blah. So you can write all of that down. You can actually do all of this using objects, of course. Makes it a lot easier. So this is we're actually doing this without objects. So you created an access called ACLN, and they're both extended. So by the way, what you type in, you have to retype in the command. Access list ACLN, it's going to be extended and permit, and here's the first command, right? Like we've always been doing it. This host to this host doing HTTP. This host to this host doing SMTP. And we create another PC1 to server B, and then we're going to do again this host to this host HTTP, this host to this host equal SMTP to 32, and so on. All right, and all you have to do, go all the way at the end and then type in access ACLN interface outside. So what you're doing is you're applying it right here. All the data that's coming in. They're allowed. So this guy, you're allowing him to go in to this server and that server, the email server, the weapon email servers, the 131 and 132, and PC2 the same thing. That's what those. That's what all of this is doing. And this is the show command. Okay, so with object groups, it's going to make it much easier. So here's what you could do with object groups. So you create an object group network, net hosts. So this is the object description. This is object group matches PCA and PCB. So you say, okay, you created two object groups. One is for PCA and one is for PCB. You create another object group called the servers. Here is the first server and the second server. And here's an object group for the services. One is for SMTP and one is for WW. So after creating the object groups, the servers, and the hosts, so look what you could do. All you got to do is then you type in right here, and this is all the command that you have to do. Access list ACLN. This is to permit PCA to PCB internal servers. So all you have to do is type in extended permit TCP object group net hosts. So net host, all of these guys are going to go to these servers. Remember, they're permit. They're permit. And also permit also to the service groups. HTTP, SMTP. All right, so please write these down. How to ACL using object groups. This is a good example, so this is because it's something new. All right, so please write that down as well. Okay, so let's take a look at NAT. When it comes to NAT, pretty much the same thing. You can have NAT inside, outside, and you can have bidirectional NAT. You know, you can have bidirectionals coming in and out, translating your IP address. Configuring dynamic NAT, so you can just write in object NAT, object network public. Here, so the public, here's the range of addresses, right? This is the public IP addresses, the global ones. Excuse me. And here's the object network dynamic. And this is the subnet of IP addresses that are allowed. And the NAT is going to be inside dynamic public. All right, you can create a policy map called global policies. You can do the class inspection defaults and the access list ICMP, extended permit ICMP, any. This is to enable the return traffic if you wanted to. Here's a good example of PAT. So you type in the object network inside NAT. Here's the subnet for it. And you type in the NAT inside outside dynamic interface. And that's it. on the inside and the outside, going back and forth, right? And they'll be translated. Static NAT, you go to the interface, you type in no forward interface VLAN. The name of it is going to be DMZ. Give it a security level on an IP address. This is configuring the DMZ, and this is the first step, configuring the interface. And then you create the objects. The object network DMC server. It has this host, and this NAT is going to be from the DMC to the outside and vice versa. And here's the static IP address. So this host is going to be given this IP address. And you create the access list, permit any host to 192.168.2.3 from the outside. And when they come in, and if he goes to the outside, on the interface, if this guy goes to the outside, we'll be given this IP address, and when he comes back, he'll be given back his IP address, and vice versa. All right, moving on, we'll be able to do that. The AAA, as we've done earlier, the authentication, authorization, and accounting. You could also do the same thing. So you can set it up using the TACX or the Radius servers. You create the username, AAA server, protocol, and in this case it's TACX, and you can type in the AAA server, TACX server to any hosts. Here's a AAA configuration for HTTP console. They enable the console, the HTTP console server, the serial, and all of these authentication that you can authenticate all of that on the TACX servers, and if it doesn't go on the TACX servers, you can do it locally. Okay. All right, so let's talk about now the MTBF. So with the MTBF, just give me 1 second. The MPF, not MTBF, the Module Policy Framework. It's a configuration that defines a set of rules for applying firewall features such as traffic inspections, QoS, to the traffic that traverses the ASA. So the first thing you're going to do is you're going to classify the traffic, right, by using the command class map. So step number 1, please write this down. You're going to classify the traffic by, before we do that. I know it's not written in here. So step number 1 when you're doing the MPF is you classify traffic by identifying traffic on which to perform the MPF. You want to create a layer 3 for class maps that contain multiple match criteria. So you use the command class map, class-map, space, whatever the name that you want. All right, so right in here. Class map, in this case it's called all TCP. Okay, class map all HTTP. So this class map, I want to make sure this class map, I want them to match the access list called UDP. Where's access list UDP? That means anybody that's doing UDP, if I called on this class map, this class map is always going to match whatever in here. You can actually match you can match UDP and TCP if you want, but this is only UDP stuff, and this is only HTTP. All right. Step number 2 is you're going to define actions. This is the policy map. What are you going to do once that classified traffic has been matched? What are you going to do with it once you get a match? Step number 2, we define any actions using the policy map command. We're going to define a policy for the traffic at layers 3 to 7. We're going to create a policy map that contains multiple class maps with associated actions. So again, we use we're going to use policy-map and then the name of the policy. All right. So for example, here's an access list called TFTP-traffic, and it's only permitting UDP permitting anybody to anybody as long as you're doing port 69. So class map called class TFTP, he's going to match this. So if anybody comes in and he matches this class map takes care of it. I mean, the good here we don't need this because you can always call the access list called TFTP traffic, but you can have a whole bunch of different access lists under this class map. Okay, match this access list, match that access list, and so on. The policy map is going to say, okay, the policy map, I want class map TFTP. So take this TFTP, whoever matched it, I want to inspect TFTP. So whoever matched this coming in doing 69 TFTP, I want to inspect it. So he's going to inspect it thoroughly, make sure that he's doing TFTP and nothing else. All right. And the service policy at the end, what are you going to do? You're going to activate it. Where are you going to activate after you inspect TFTP? Okay. Activate the policy map on the interfaces. You're going to create a service policy that applies a policy map to an interface or all the interfaces. Okay. So in this case, activated globally, in this case, it's going to be on all the interfaces. All right, so please write this down. This is implementing the MPF. This is a good example where you create the class map, the policy map, and the service policy as well, those 3 steps to do the MPF. First, you create the access list. You can create a whole bunch of access lists and take the access lists, put them under a class map, match whatever which one you want. The policy map, what are you going to do when they are matched? Bring in all the class maps in here, inspect them, and then apply them using the service policy command. All right. And here are the default policies. These are done by default, so you don't have to worry about that. And that's it for chapter 9. All right. It's a little bit strange. I think the best thing to do when we're going to do this in lab, so I want you to take your time doing this step by step. It's going to take a little bit of time, but the best way to do it is to do it with hands-on. All of the material that are covered, we already know this already. All of these are stateful, by the way, firewalls, as you can see in the summary. But it is best you'll be able to comfortably understand this when you do it again in the lab. All right, so until we meet again in chapter 10, make sure you submit these as homework, all the notes that I asked you to do. And I'll see you in chapter 10.